One of the areas that a lot of students are struggling with are logs. Now, they are not really that difficult, but if we don't get it, they are. Okay, so let's have a look. So we have to write 1 over 81 in the form of 3r. So I am not changing the value, I'm just writing the same value in a different manner. So the reason why I'm looking at this question, because it's a great way of explaining how the logs work. Okay, so let's consider what am I having here? What are the elements? So this number 3, that it is taken to a power, that's what we call base. And then we have our r, which calls power. And then we have equal, and then we have outcome of that multiplication, and the outcome of multiplication is called product. Okay, so what am I looking for? I do have the product, I do have the base, I'm looking for power. So in maths, as you know, very often we replace words with sign. For example, instead of saying plus, instead of writing plus, we say plus, but we write that. And that means plus. So when I am looking for power, because that's what I'm doing, I don't know what that value is and I'm looking for it. So instead of saying I am looking for power. So instead of writing all of that, in maths, we have a shortcut. We say log. That means I am looking for power. What's the base? The base is 3. What's the product? 1 over 81. And the outcome of that will be my power. So always remember, when you are looking for power, log, then we are saying what is the base, what is the product, and the outcome of that calculation will give me power. And then we put that in our calculator. On your calculator, you should see bottom to press that will have those type of 2 squares. That's the one you are using. You press that, that's the same what you should see on your screen on the calculator, and that's where you put your base, that's where you put your product. So when we put that in our calculator, we get that the value of r is -4. So therefore, that means here that 1 over 81 can be written as 3 to the power of -4. Okay, let's have a look at next part of this question. Okay, the following is an expression in x where x is greater than 0, and then we have an expression. There is no equal sign, so therefore we are not finding the value of the letter, okay? Write this expression in the form. So this is the form I have to write it. So I have 3 logs and I have to write it as 1 log. So basically the same number, the same value, however in a different form. Don't forget with maths, for example, I can write number 30, or I can write that same value as 10 multiplied by 3, or I can write the same value as 12 minus 2 multiplied by 3, isn't it? So this is the same idea that I am not changing the value of this number, I'm just writing it in a different way. So how do we do that? Well, we have formulas in our table that we basically use to replace what is written in one way to write it in a different way. So let's get our formulas from the log tables. Page 21, here we have the formulas. And then some more here, but for now, that's the one we're going to be considering. So how do we use these formulas? So we basically look at what we have, and then we are looking at formulas and saying, well, is there a formula that looks like it? So what do I have? I have 2 logs that are added, or I have logs that are subtracted. So I'm saying, okay, the very first formula in my table is saying that if I have 2 logs that are added, I can write them in this form. So those two logs can become one log. Or I can look at it different way. Here I have a formula that is saying when you subtract two logs, you can replace that with one log. So I could take these two and replace with one log. Now, it doesn't matter which way you're going to go, you're going to arrive at the correct answer. Okay, so let's apply that. So I've rewritten those, our equation and the formula so that I can show you how to apply that. So we are looking at changing these two logs to become one log. Okay, so let's compare what we have. So this is the side we have. Our base, so our value of A, and don't forget in your formula, always the letter will represent the same number. So our value of A is what? 100. So if I remove A from here and replace with my 100, so we are putting 100 here, 100 here, oops, and 100 here. Okay, then the next thing, I have X, they have X, so that's fine, it's X. Let's just replace that X with a different color so we know that that is not just a formula. Okay. And then my second one, 18. So Y here will be 18. That means that Y here is 18. So if I remove this Y and I remove this Y, therefore I have 18 and 18. So instead of these two logs, now I can write just one log. Okay, so let's write it. Log of 100, and then we have X multiplied by 18, or 18 multiplied by X, doesn't really matter. Log 103. So again, we need one log. So we were saying those two logs can become one log. So again, let's get our formula from the table. So that's the formula that is saying if you have two logs and they are subtracted, you can change to one. Okay, so again, we are comparing. So our base is 100, 100. So we can replace that letter A with 100. So 100, 100, 100. Then the first product here is X multiplied by 18. So instead of this X and instead of this X, we're going to have, let's get a different color, X multiplied by 18 or 18 multiplied by X, doesn't really matter. And then my second one product is 3. So we're going to replace this Y and this Y, and in that place, we're going to put 3. Okay, so now those two logs can be replaced with one log. So therefore, log of 118 x divided by 3. Now I'm saying to myself, actually 18 divides by 3, isn't it? So that means that's 6. So therefore I can say log of 100 is the product of 6x. So I'm saying, okay, that's fine. I got all the 3 logs to one log. Now let's compare that to what we need to have. So they're saying we should have P log 10 kx, and then they are saying where P and K belong to R. So basically what they are telling us that this and this is a number. I'm saying, okay, so what's the difference between what I should have and what I have? Well, log is correct. The problem we are having, I have 100, they have 10. So they have a different base. I have X, that's fine, they have X. I have a number, they have a number. But the problem is the base, I have a different base. So what can we do? In your table, we have a formula here that is allowing us to introduce a new base. So let's have a look how this formula will work. Let's move that a bit. Okay. So this formula, this is the situation that I'm having. This is my situation, but I need a new base. So again, let's observe. The base here becomes product here, and then the product becomes product on top. But what's new is that value of A. So this is what allows me to introduce new base. And that's what I need. I need base 10. Okay, so again, I'm going to write it out so that I can replace those values so that you can see it, because that's how easy it is. You just write it, then you take the row and you row out the letters with your own values. So that's what we said. We have 100, so our B here is 100. So we're going to replace B with 100. So 100 and therefore 100. Our X is not just X, it's 6X. So we're going to replace this X with 6X. And then I can bring in any base I want. Now the one I want is 10, so I'm going to have 10 here. Let's get a different color, maybe black. Oops, that's not what we wanted to do. 10. So now I have a new value. So the same, new number, new expression for the same value. So instead of log 100 of 6x, I have log 10 6x over log 10 100. But I'm saying, but hold on a minute. Yes, now I have the log, I have 10, I have number, I have x, so that does look like it, but they don't have fraction. I have fraction. They have a number in the front. But all of that here are numbers. I'm saying, well, what value is it? So I'm taking my calculator and I'm putting log of 10, the product 100, pressing equal, what do I get to? So log of 10, 6x over 2. Now, every fraction that you have, always remember what's on top of the fraction can be written here beside the fraction. Yeah? And if I'm removing everything, what I have to leave here is 1. Yeah, because when something is written beside the fraction, that means it has a multiplication sign. So that means I'm going to have a half, and then I'm going to have my log 10 6x. And yes, now I fulfill the condition. I have a number in front of the log. I have the base 10. Then I have a number beside x. Logs are almost every year you have a specific question, your leaving cert, that's algebra question, and it's just log question. It has been showing for the last few years, so I will say it is a good practice. Please pay attention to logs because there is a very high chance that you're going to have that in your leaving cert.